Hello, this is Vipul Purohit and I welcome you to my YouTube channel. You must be knowing the title of this video. Yes, it is bonding in polyatomic species. And this is part 4. I'm very sure you have seen all the 3 parts, previous one. No? Don't worry, just share. The link of the previous 3 videos you can find out in the description box of this video. So please, you can go through it so that you understand this concept very well. Alright? So, without wasting any time, let's start with the today's edition, and that is about the bonding in trihydrogen molecular ion. So bonding in H3 plus ion. Okay, this is trihydrogen molecular ion. Why I use the word molecular? The reason is because that they are going to be bond existing, so that's why it becomes a molecule, and at the same time it has a charge, and therefore I call it as a ion. So it is trihydrogen molecular ion. So this is what we are going to discuss in this particular edition of this video, the bonding in H3 plus molecular ion. So to begin with, when we talk about an H3 plus ion, experimentally it has been found, experimental is something which is going to be actual results which are being found out. It's not factual. Theory factual hota hai, experiment actual hota hai. So experimentally it is being found out that this molecular ion has a equilateral triangular geometry. I hope you understand this word, equilateral triangular geometry. Okay, triangle तो है लेकिन वो equilateral है. Okay, all sides are equal. और उसका bond angle कितना होगा? जी हाँ, 60 degree. So the bond angle has to be what? 60 degree. So the arrangement of the 3H will be in this way. Okay, H, H, H. इस तरीके से उसका arrangement होगा. Okay, this is what experiment says. So first of all is, so let us understand through SALC theory. And then see whether this SALC theory is according to this or not. अगर है तो it's fantastic. अगर नहीं है तो फिर we have to bring about some modification in the SALC so that it comes according to the experimental results. Okay, because अगर theory में कोई भी गड़बड़ है तो theory में modification लाना है so that it matches with the experimental results and that you know it very well. Alright, so let us start now on the basis of SALC how this bonding can be explained. So what we do is, on the basis of the SALC theory, let us assume that the 3 hydrogen, initially let us ignore the charge, that is a positive charge, that we'll look into later part. Okay, पहले हम सिर्फ 3 hydrogen atoms consider करेंगे. So let us consider the 3 hydrogen atoms as HA, HB as well as HC. Okay, now according to SALC you also know that one of them is a central atom, the remaining are peripheral atoms. ये मैंने आपको बता दिया था in my previous videos. Alright, so यहाँ पर भी we are going to consider any one of them as a central atom और बाकी के हम लोग क्या consider करेंगे? Peripheral atoms. तो let us take it for example, अभी A, B, C मैंने denote किया है, तो obviously आपको भी पता है कि B center पे आएगा, A और C आजू बाजू में आएंगे. So what we do is that HB is going to be considered as a central atom, and therefore we say HA and HC are peripheral atoms. आई बात समझ में? Okay, once again I repeat, the 3 hydrogen atoms are being considered as HA, HB as well as HC. उसमें से one of them is going to be the central atom and that is what? HB, और बाकी के 2 जो है वो हम peripheral atoms consider करेंगे और वो है HA और HC. Next thing is, we go into the electronic configuration. Now as far as hydrogen is concerned, my dear friends, electronic configuration is the simplest one and that is 1s1. Okay, now you know the sequence also very well, so let me first of all make you understand the electronic configuration. It is, I'm not going to write down 3 times, you all understand this, it is going to be 1s1. Okay, all the 3 atoms are of the same elements. Now what are the steps involved? Okay, the step is, we don't directly get the molecular orbital. याद है ना? Yes, molecular orbital starting में नहीं मिलेगा. पहले तो क्या होगा? Orbitals of the peripheral atoms combine and we get what? Group orbitals. फिर ग्रुप ऑर्बिटल कंबाइन होगा ऑर्बिटल ऑफ द सेंट्रल एटम के साथ, और तब जाकर हमें क्या मिलेगा? जी हाँ, मॉलिक्यूलर ऑर्बिटल। तो पहले वहां से शुरू करते हैं, कहां से? ग्रुप ऑर्बिटल से। तो ग्रुप ऑर्बिटल के लिए कौन सा ऑर्बिटल्स कंसीडर करना है? ऑर्बिटल्स ऑफ पेरिफेरल एटम्स। यहां पर पेरिफेरल एटम्स कौन से हैं? Ha एंड Hc। तो व्हाट यू हैव टू से इज 1s ऑर्बिटल of Ha and Hc, they are going to overlap, which results in the formation of, अब मैंने आपको बोला था कि जितने ऑर्बिटल्स ओवरलैपिंग में इन्वॉल्व है उतने ही ऑर्बिटल्स मिलेंगे। सो 1s ऑर्बिटल ऑफ Ha, 1s orbital of Hc. So that means there are how many orbitals? 2 orbitals. So when 2 orbitals are involved in the overlapping, it's very obvious you will be getting what? 2 group orbitals. So it overlaps, resulting in the formation of 2 GOs. Okay, I hope you know this very well. Those who are associated with me, so they know all these terms very well. Okay, so they are called as group orbitals. Next thing is, जब हम orbitals की बात करते हैं, the orbitals are occupied by electrons. Electrons have got 2 properties. कौन सा है? The particle property as well as the wave properties. But here in this case, we are going to consider the wave properties. And that's why, whatever the discussion is all about, that is dependent on wave. Dependent दोस्तों, मतलब it is function of wave. And that's why we call it as what? Wave function. Okay? And that wave function will be denoted as what? Psi1 and Psi2. Okay, this will be denoted as what? Psi1 and Psi2. Understood this part? Okay, up to this I guess everything is clear. So once again I repeat, 1s orbital of Ha and Hc, which are peripheral atoms, they are going to overlap, resulting in the formation of what? 2 group orbitals, and those 2 group orbitals will be denoted as what? Psi1 as well as Psi2. Now when these group orbitals overlap with the 1s orbital of Hb, then it results in the formation of what? A molecular orbital. Okay, then it results in what? The formation of a molecular orbital. But my dear friends, that overlapping is based on what? Yes, symmetry, similarity. And that similarity is in terms of 2 points. One is the shape of the orbitals. Here no issues at all because we are talking only about s orbitals, और कोई ऑर्बिटल हम लोग ने कंसीडर किया ही नहीं है, so उसका तो कोई टेंशन नहीं है. s orbitals all of them are spherical. तो एक सिमिलैरिटी with respect to the shape of the orbital आता है, and the second similarity is with respect to the sign which is being involved in that particular orbital. ये मैंने आपको पहले ही बोला था. ओके, प्लस एंड माइनस इन दिस पर्टिकुलर चैप्टर आर नॉट चार्जेस, दे आर साइंस, and that sign is an indication of what? Directions. So direction may change and then that overlapping doesn't take place. Okay, so that is what you need to remember. So the combination has to be such that there has to be a similarity with respect to the shape as well as the sign, and then it results in the formation of what? Yes, the molecular orbitals. Alright, so we will be discussing about the formation of this molecular orbitals, okay, on the basis of the diagram. Then only we can understand exactly which orbital is similar to which of the group orbital, whether it is similar to Psi1 or whether it is similar to Psi2. Alright, but then I guess up to this part everything is being absolutely clear to you all.